So these are your video notes for 1-6 linear systems. And you'll see there are a few examples I'm going to skip along the way, so just don't worry about those. They're not things that I'm really concerned about at the moment. Page 21 in the Student Companion, that's a workbook that I've given to my students who are present in school and are not virtual. This is the same thing that you completed in Savas Online, so it is actually the Explore and Reason. I did want to go through that so that you guys could see what the answers were for that and go through and check your work. So this was the series of questions for that. You had this thing and you had to show or estimate where the solution was. These were your answers that you should have. Part A did ask for an estimate. So the book's estimate, because again, this is sample student work, was 3.1 and 4.8. The actual solution is 3.2 and 4.6, so just keep that in mind. You can verify those coordinates by substitution, and yes, the point where the lines intersect is the solution if you use, again, the correct number. I'm not sure where the book got the numbers that they used. And you could do this as long as the answers were rational. Solving algebraically is going to be more efficient because you might not be able to exactly guess where the lines cross. And that's going to be the basis for linear systems. We are going to be looking at equations mainly today. There is a section on inequalities and seeing where inequalities overlap, but that's not something that I'm really concerned about at the moment. So you have your essential question: how can you find and represent solutions of systems of linear equations and inequalities? And again, we're only doing the equations with this. So this is our first problem. This is actually the same type of thing that was on the summer packet, so I'm going to go through this a little quicker than I will the next thing that we're going to talk about. I'm only going to solve this using elimination because elimination is the main method we're going to use for, I think it's example 3. So I want to make sure that we are quite confident with that. So I have my top and my bottom equations, so I can call these equation 1 and equation 2. And if I'm going to eliminate here, it would make the most sense to eliminate y because the y's are already opposite in value. So I can go ahead and add those together. When I do, the y's are gone, and I have 2x is equal to 7, which means x is equal to the fraction of 7/2. So once you have x, you need to find y. I'm going to take the 7/2 and plug it into the top equation. So if I plug into the top equation, I have 7/2 plus 2y is equal to 3. I would subtract the 7/2 from both sides to work on getting the y by itself. So I have 2y is equal to -1/2. 3 minus 7/2 gives me -1/2. Divide by 2. If you divide -1/2 in half, you're going to end up with -1/4. So my solution here is called an ordered pair. That is 7/2 and -1/4. We could plug that in to the original problems to make sure that the left and the right hand sides were equal if I wanted to check my answer for that. So you have this system of linear equations. It's going to be 2 or more equations that are going to use the same variables. There is actually no limit to how many equations you could possibly have, but as a general rule, however many variables you have, that's how many equations you need in order to get a solution. And then your solution of your system is going to be the set of all the coordinates that simultaneously make the equations true. This is the example we're going to skip because this deals with some inequalities. So we're going to skip on to that, and we are going to example 3. And this is part A. How can you solve a system of equations in 3 variables? Solving in 3 variables is not something you will most likely have to do for your career unless your career is, being a math teacher. Then you might have to teach it to students. Because typically when you get into these upper amounts of equations and variables, you are going to be using some type of tech to solve the system. These systems could be 10 equations, 10 variables, 20 equations, 20 variables, and it just doesn't make sense to solve them by hand. However, the reason I'm making you guys solve these by hand is because this really emphasizes being careful with what you write down, being aware of your negatives, making sure that you are careful with your multiplication, So all of those things that lead to success with other types of mathematics. Just being very careful and very precise with what you do. So I'm going to go ahead and number these. There's number 1, number 2, and number 3. So your first step, or actually our main goal here, we start out with 3 equations, 3 variables. I'm going to whittle that down to 2 equations, 2 variables, and then whittle that down further to 1 equation, 1 variable. Once I get down to 1 and 1, I should be able to easily solve for one of the variables and then plug into the previous level to get the other 2 letters that I need to find. So to start off with, you want to pick 2 equations, and you want to eliminate a variable in those 2 equations. Well, I am going to eliminate z, and I'm going to match up the first and second equations. I see my z's are already opposite, because in equation number 1, I have a minus z, and in equation number 2, I have a plus z. So here's number 1. 2x plus y minus z is equal to negative 10. Always double check and make sure you are copying things correctly. Equation number 2 is negative x plus 2y plus z is equal to 3. And then I'm going to add those together. So my z's do add out. I have x plus 3y is equal to negative 7. So that's the first step. Eliminate a variable from 2 of the equations. Now you are going to pick 2 different equations and eliminate the same variable. You have to use equation number 3, but you will have to reuse number 1 or number 2. So if I have to use 3, I think I'm going to match 3 up with number 1, because number 1 already has a negative in the z position. So to turn that into the opposite of what I have in number 3, I'm going to multiply that top equation by 3, and then my bottom one I'm going to keep the same. So my new top equation is going to become 6x plus 3y minus 3z is equal to negative 30. And my equation number 3 is going to become, it's not going to become anything, it's going to stay the same. X plus 2y plus 3z is equal to 13. So whenever I match those up, let me just double check and make sure I multiplied everything I was supposed to. My z's are going to add out. I'm left with 7x plus, not 6, plus 5y. Again, it's very careful, or very important that you're very careful with what you're doing. 7x plus 5y is equal to a negative 17. So now I have these 2 equations that I'm going to be combining together. And I am going to scroll a little bit. My little video box gets in the way here some. Between these 2 equations, my new blue and my new red, it's probably going to be easiest if I eliminate the x value. So in order to do that, I have a positive 7x in red. I have a positive 1x in blue. I'm going to multiply the blue by a negative 7. The red I'm going to keep the same, so I'm actually just going to rewrite this equation right underneath over here. So when I multiply that equation by negative 7, I have negative 7x minus 21y is equal to a positive 49. When I add those together then, my x's add out. I have a negative 16y is equal to a positive 32. You can divide, and you end up with y equaling negative 2. Now, aside from the next example that I'm going to show you where there's something different that happens, the questions that I've picked out for this are going to have answers that are integers. Whenever we test on this, your answer will be an integer solely because I want you guys to have some way to check your work. It is possible to get fractions within these, but I want you guys to really just focus on getting the correct thing, getting the process down. So I want you to have some way, like if you get to this last step and you get y equals 2 over 3, you know you made a mistake somewhere because the answer shouldn't be a fraction. When you're doing the Math Excel, there may be a question or 2 that is a fraction, so just be aware that that is not a hard and fast rule unless it's something that I actually created. So now, we have y is equal to negative 2. However, we are still missing a value for x, and we're still missing a value for z. So to find x, I need to go back a previous step to either my new blue or my new red equation, and I need to plug the y into one of those to solve for x. So I'm actually going to use this equation over here, the blue one, because I have more space to write below it. So this equation is going to become x plus 3 times negative 2 is equal to negative 7. So if x minus 6 is negative 7, add 6 to both sides, you get x is equal to negative 1. So now I have x and I have y. The only thing I'm missing is z, and you can use any of the 3 original equations to find z. I think I'm going to use number 2. So I have a double negative 1 plus 2 times negative 2 plus z is equal to 3. Well, my double negative 1 is 1, so I have 1 minus 4 plus z is 3. That's negative 3. So whenever I add the 3 to both sides, I get z is 6. So x is negative 1, y is negative 2, z is 6. To write this as your ordered triple, not an ordered pair because we've added on the z dimension, we would list them alphabetically with commas in between. So your solution is negative 1, negative 2, 6. And that is your ordered triple. I talked a little bit about the meaning behind the z space, the z dimension, because these 3 are all lines. They're not lines in the traditional sense that you may think of lines from before where they only had x's and y's. So typically you guys have, you have the x line. So this is your x dimension. Your x dimension is your left and right movement. You have the y dimension, which is going to be your up and down. So that's 2 space. The z dimension would be the axis coming straight towards you. So you have your x, you have your y, your z would be the one coming straight out. Z is what allows us to exist in 3 space. So instead of these lines being graphed just on, your 2-dimensional paper, they would almost be graphed in space. So they would be hanging out in space there. And there's a whole lot more on 3-dimensional graphing and stuff if you go and look online. It's not something I wanted to focus on for this class, but again, I did want to introduce you guys to the idea. Okay, so now we have part B. Part B is the same type of problem as what we had in part A, but this one does have something weird that happens in it. You may find that the weirdness happens in your first elimination, in your second elimination, or in your third elimination. It just all depends on which equations you match up with first. And you'll see what I mean as we go through this. So I am going to eliminate y. And again, if you were doing this on your own, you may pick different equations to match up. But I'm going to eliminate y, and I'm going to match up equation number 1 and equation number 2. My y's are already opposite, so I am just going to recopy those. So equation number 1 is going to be 2x minus y plus z is equal to 3. And then number 2, x plus y plus z is equal to 5. The y's add out, and you have 3x plus 2z is equal to 8. So now I need to pick out 2 different equations and eliminate the y. I'm going to go ahead, I have to use number 3. I am going to match that one with number 1. So in doing so, I'm going to have to multiply the top equation by 2 because I have a positive 2y down in the bottom. So I want to get a negative 2y up in the top. And then I'm going to keep my equation number 3 the same. So number 1 is going to become 4x minus 2y plus 2z is equal to 6. And then equation number 3 is negative 4x plus 2y minus 2z is equal to 0. And you can see here's where the weirdness starts to happen. My x's add out, my y's add out, and my z's add out, and I'm left with a 0 on the left-hand side. The right-hand side is a 6. Well, 0 isn't equal to 6. 0 is never equal to 6. This is never something that is going to be a true statement. So this system has no solution. If you had chosen to match up number 1 and number 3 to begin with, you might have gotten the no solution in your first step. If you had chosen to match 2 and 3, you wouldn't get the no solution in the second step. It wouldn't happen until you did the third step where you matched up the new red and the new blue and the new red equations. But it would happen somewhere. You would get a no solution in either the first, second, or third elimination, just depending on which values you matched up first. So I hope that this was useful for you in going through this. We will be doing a worksheet on these same types of questions. I do have another one worked out that goes along with that assignment. So please let me know if you have any questions at all about these. Again, focus on making sure that you are careful with how you're carrying your negatives. Make sure that you multiply everything in the equation whenever you're supposed to, because that's usually where we see the most issues with this type of work. Just like with everything else that we do, if you're struggling with this, if you don't understand something in the video, reach out to me if you have any questions.